let's see your thoughts on it. Simple. You will be starting from index 0 first cell and you need to move on to the last cell, and we need to return the shortest path. The the only difference here is what he's trying to say is you can move in 8 directionally connected. So let me explain it. Uh, we need to figure out a shortest path. Let's see how can we do that. Okay. Okay. So what he's trying to say is you always start from 0 0 cell, and you should reach to the 1 comma 1 cell. We need to find out shortest path. So to reach shortest path is equivalent to reach last cell, number of cells you visited, so which is going to be the shortest path. But from a given cell, so this is your cell, so we discussed only vertically, horizontally, but you can also move on to diagonally. So you can take 8 directions. So this is diagonal direction, so you can take 8 directions. So that's what is trying to say. Let's say you are at first, let's talk about how do you come up with the 8 directions, right? So if you are at 1 comma 1 cell, down is going to be what? 2 comma 1. So what does it mean? You are just incrementing the row, there is no change in column. Correct, nobody? Yes or no?
Yes.
Ajay?
Yes, Shunu.
So I'm just highlighting here, so which is going to be 1 comma 0. And if you want to go up, so what is going to happen? So there is no change in so column, but row will be changed, so you can represent it as minus 1 comma 0. Okay, similarly to the right it is going to be 1 comma 2, so there is a change in column, so that it is going to be 0 comma 1. To the left it is going to be 0 comma, sorry, 1 comma 0. So there is no change in row, but change in column, so you can represent it as 0 comma minus 1, right? Similarly, if I go this direction, what is going to happen, buddy? If it is 0 comma 1 means definitely it is going to be 0 comma 2, right? Yes or no, buddy? Yes or no?
Yes.
So how do you represent? So because this cell is 0 comma 1, so the next cell is going to be 0 comma 2 only, no? Or do you want me to, I think this
No,
way,
understood.
let me draw this way so that it will be smooth. So 0 1 2 3 4, oh, sorry, 1 2 0. Okay, so what is this cell? 0 0 0 1 0 2 1 0 1 1 1 2 2 0 2 1 and 2 2. Correct? Now closely see here, so I am just highlighting through green. So right means, so only the change in column, so it is going to be 0 comma 1. Left means again change in column, same row, so it is going to be 0 comma minus 1. You are decrementing the column. Down means you are incrementing the row, so 1 comma 0. Up means you are decrementing the row, so at minus 1 comma 0. There is no change in column. Now diagonal, so see diagonal. So when you are going diagonal, so what is going to happen? There is a decrement in the row and increment in the column, right? So it is going to be minus 1 comma 1, isn't it? It is first row and it is went to 0th row, correct? Yes, no, so nobody. And it is first column, it went to second column, so that minus 1 comma 1. Is this clear, Kalyan?
Yes.
Now similarly, if you come down, so what is going to happen? There is an increment in row, decrement in column, so that what is going to happen? It is going to be 1 comma minus 1.
Minus 1.
Similarly, if I come this way and both got decremented, right, row and column, so that it is going to be minus 1 comma minus 1. If I go this way, both got incremented, so 1 1 become 2 2, so that it is going to be 1 comma 1. So totally how many directions we got? So minus 1 comma minus 1.
8.
So yeah, so minus 1 comma minus 1, so minus 1 comma 0, minus 1 comma 1, and yeah, 0 comma minus 1, 0 comma 1, then minus 1 comma minus 1, 1 comma 0, and 1 comma 1. So we have to move, we can move any of these directions, okay? And the problem statement says the given matrix has either zeros or ones. 1 means that is all, you cannot take that path. 0 means you can take that path. So we need to start from 0th first cell, and we should reach the right corner last cell, and we need to find out how many shortest shells you need to reach to the last cell, bottom right last cell. So let's take the given input. So you have 0 0 0 and 1 1 0 and 1 1 0. Okay, so let's see, this is your thing. So there are multiple ways to reach to the bottom cell. So let's see what are the ways you can see. Okay, so one way is what I'll do, I'll take right here, and I cannot take down because it is 1. I can take right here, then down, then down. So the number of cells I visited here are 5, so here it is 5. The other way is I can take here, I can take diagonal, then I can take down. The number of cells I visited here is 4, so that answer is 4. Is the problem statement clear, buddy?
Yes.
Kalyan?
Yes.
Now how do you want to implement this?
I mean, we'll explore what are the possible paths we can take and choose the one with the minimum value.
We take the count, and out of which count is minimum, we take that count and return.
The second idea should be we should target to reach in the row -1, column -1, which is the end of the grid, which is
How
n
do
minus
you-
1, n
no,
minus
I
1.
understand exploring is fine, but how do you get the shortest path? So when you
Shortest
keep
path
on
will happen if we go diagonally only.
now how do you know that? Okay, so if I go this way, if I go diagonally only, I get the shortest path here. But let's say you have the size is too much, right? So the size can be 100, the length can be 100, so you get 100 by 100 grid.
Correct.
So how many diagonals you could take, or how many? So you doesn't know that, right? That's where you need. Don't worry about anything. That's where you need breadth first search. So let's see how do you do that. So first I am starting from. So this is 0 1 2 and 0 1 2, right? Okay. So now let's move on. So I need to start from 0 0 index, right? Yes or nobody? Please. I need to start from 0 0 index, right? If I start from 0 0 index, I have only one option, right? Because other options are invalid. All other diagonal options are invalid, correct? Yes
Yeah.
or no? So I have only, if I start from 0 0, so let's say I visited 1. Okay, so because you visited 0 0 cell, okay, let's forget about visiting count, later we will add. So as part of 0 0, and you will be adding 0 comma 1, correct, nobody? Please,
Yeah.
Kalyan?
Yes.
Now as part of 0 comma 1, what are the indexes you are adding? Closely see. These are the valid indexes I am adding, right? Yes or no?
Yes.
So now as part of 0 comma 1, I am adding, what are the indexes? 0 comma
1,
2
2.
and 1 comma 2. Correct? Correct?
Yes.
But we select 1, 2 because that way we
No, no,
can
no.
reach.
Don't worry about it. Don't
First.
worry about it. Okay. Now let's move on. Now if you consider this as a, so this is one level, and this is another level, and this is third level. Okay. If you consider this as a one level, so as part of 0 comma 2, what are the elements you could add as part of 0 comma 2? This one, only this one, right? Yes or no?
Yeah.
But
Yes.
it is already visited. Yes or no? Which was already visited, na? Is
That
this
side is already visited.
Yeah, this is already visited through this, right? By the time you come here, somehow you will maintain a visited array, so which is already visited, so that you don't ignore, you will ignore it, correct? Please?
Yes.
You will ignore it. Now it means as part of 0 comma 2, none of the elements were been added, correct? Please?
Yes.
Now, okay, so none of the elements are added. Now you will have 1 comma 2, right? Now you will have 1 comma 2. So if you get into 1 comma 2, so definitely you have this one and this one, other ones on top and corner. So all other elements were already been visited. If you closely see, this is visited, this can't be taken, and only this is not visited. So definitely you will consider that element. So definitely you will consider that element. So which is going to be 2 comma 2. So when it is 2 comma 2, it means you just need to count. You just need to count the distance, right? That's it, right? So closely see what I'm trying to do. So what I'm trying to do, I'm just taking one additional element. Okay, so when I am at 0 cell, the visited count is 1. Perfect. So because I visited 0 correct now, buddy? Please. Now from
Yes.
0 cell, I get into 0 comma 1. Here the visited count becomes 2. Correct?
Yes.
Ajay?
Yes.
Now from 0 1, I took 2 directions. From 0 1, I took 2 directions. The shortest path can be in any direction, correct?
Yes.
So here the visited count, earlier count plus 1. If I take this count, this direction, here also 3. If I take this direction also, here also visited count 3. Because you can take only one path, right? Yes or nobody? Either this path, this is more critical. So either this path or this path, correct?
Correct.
Correct now, Ajay?
Yeah.
The visited count remains same. So because with respect to this cell, you come from here, right? So this cell visited count is 2. So 2 plus 1, which is going to be 3. With respect to this cell also, you come from here. So 3 plus 1, so which is going to be 2 plus 1, which is also going to be 3. Now let's move on. So of course this cannot add anything, because by then you traverse, none of the elements found. Now when you come from here to here, now you will just take visited count top plus 1, so which is going to be 4. Simply you return 4. Done.
Is the 4 not same as in the label?
It's not like that always. Yes, it's always same as level, correct?
Yes. Why?
You
Because
always
we
have
can-
a,
if we
yeah,
which is
you
the
can-
last element, then we can return the level.
yeah, you can simply return that level. Nobody, no. It's not
No,
same
no,
as
it
level.
will not be like that. No, no.
Because, for example, let's say you have 0 here.
Because sometimes for
Let's
the
say-
shortest
let's
path,
say you
have
have
to go
0
left,
here.
left, so.
Let's say you have 0 here, then you will come here, and you have 0 here. Then you will come here. So because here the level becomes same, but visited count will remain different. There is a difference in,
If you see the third example, Shinu, in this diagram at the bottom, you have mentioned.
yeah,
There, if you see 0,
Yeah,
0,
yeah.
there the output is 3, right?
yeah. No, here levels will be differs, right?
Mm-hmm.
So
The
Yeah,
shortest
so-
path is not same as level.
yeah. Here we need to consider based on the visited cell count, not based on level. The level can
Level.
have more than one cell, but if you go with the level, you always get a shortest answer. In this case, it is valid, but you always get a shortest answer. Clear? Now, what is the time complexity?
Order of n square.
Yeah, so
N.
obviously n square, right? So because both are n, column length and row length. In this case, both are saying same. So it is going to be
Okay.
order of
Okay.
n square. And what is the space complexity?
Same n square.
Why? Why it is n square?
Because for the visited one, we need to maintain.
Yes. So yeah. So one
Another
is for visited,
grid.
so which is going to be
Yeah.
order of n square. And do you need any other thing?
We need one more to keep that with like that this nodes like what we're
Yes.
visiting.
Yes. So one more for q, right? Yes or no?
Yeah.
Q. So
Yes, Q.
Yeah, in worst case, let's say it's not n square, but in worst case, you can consider approximately equal to n square. Fine.
Yes.
You feel these problems are so simple after solving those DQs, right? Ajay, Kalyan.
I think we have solved similar problem like this in rotten oranges and some sort of those problems.
Yeah, yeah, but this is quite small variants on to the root
Correct.
analysis.
The trick is these problems are not easy ones, but compared to what we are doing since last 3-4 days,
Your
all
mind is
this would be easy.
habituated to it. That's what I'm saying, right? The more we go, the better you feel.
Yeah.
Okay, so can you tell me the directions, buddy? So
0 -1 -1 0
Minus 1.
1 0 0
so
1,
let's say
then
what is this
-1 1.
direction? What is this direction?
Shinu, doesn't matter. We can just put 8 numbers there. The order doesn't matter, right?
I want to hear from you, man.
Okay. Okay, this one will go, yeah, left. 1 0 0 1. 1 0 is basically, yeah, row column, right? Yeah, down.
Now
-1 1 1 -1.
it will go to which direction?
Left corner, left corner top.
What do we call right top, right?
Okay, okay.
Top, right, right? Yes or no?
Top right, yes. Yeah, yeah. -1 -1. Okay. Bottom left.
Yeah, top left, man. When it
Oh,
becomes
sorry,
right.
yeah. Minus,
left,
minus. Yeah, minus.
Bottom right will be 1 1.
1 1, yeah.
That's why
Bottom
I
left will
told
be
to
1 -1.
yeah,
1 minus 1, bottom left.
bottom right it is.
1 minus 1 will be bottom left.
Left.
Okay, done. So we are done with the directions. Okay, we'll do one thing. We'll move this guy to here. Integer list of integer arrays. Get neighbors. Okay. For a given row, I just get the neighbors. So let's move this guy here so that our code will be cleaner. Okay, so for that, so first we need integer yan equal grid dot length. So
So, no, yesterday's problems are medium problems, right? The
yesterday-
bound one, what we solved yesterday.
No, man, those are hard only.
That is hard
Counts.
one.
No, you mentioned under intermediate level.
Doesn't matter. It's not about.
No, that, yeah, that doesn't matter. But today's problem, we have put it in the advanced level.
Today's problem.
We have put it in the advanced levels. Not this matters.
It should be vice versa.
No, what happened? I was discussing DQ, right? And I just explored DQ problems and added there. That way.
Okay, okay. No, those problems are really of good quality for sure. Yeah.
Okay. And today I moved two problems to the sliding window. Actually, these two problems were there in DQ, but I don't think we don't need to apply DQ, so you can try to
Okay.
solve. I just moved
Sure.
and one problem to the bottom. Actually, there are two problems in the intermediate level, and one problem I moved to
Yeah.
the bottom. So this problem, this one I moved to the bottom because it needs a sorting logic. So I don't want to trouble you, so I just moved to the bottom.
Thank you.
Okay. So, and we also need visited array. What is a base case? Please tell me base case.
We should not go out of the bound.
Okay, if you want to return -1. So what is saying, if you are not able to reach last cell, right, you should return -1.
Right.
So what is the base case? So I'm going with the queue. So this is my queue. New linked list. Okay. So what is the base case? Tell me. If
If you
bottom,
don't find it, just return it. If you don't find the n
yeah,
minus
in
1,
case if grid of 0 0 is not equal to 0, right, or 0, if it is 0 then only you can traverse, right. Grid of n minus 1 is not equal to 0, then you can blindly return -1, right.
Correct.
So that's a base check, otherwise we will try to explore. Okay, so what is our job? So first we will add first grid, so q dot add of new integer of, so cell 0 comma 0 and distance is 1. Okay, so I'll just maintain simple array. You can come up with the bean and do that. I'm just doing that, and I will also mark visited of 0 0 visitor of 0 0 to true. Okay, so now it's time for me to get into queue. So as long as my queue is not empty, then what is my job? So first I will take the current cell, right. So from the queue dot pool, right. So I'll take the current cell. So here you will get a row, so cell of 0, and column cell of 1, and the distance cell of 2. Correct na? Correct na, buddy? And if it is not, so in case if this row is equal to n minus 1 and column is also n minus 1, you are done with the logic na? You can simply return the distance plus. Correct? Please, buddy.
Yes.
Sorry, I was on mute. Yeah, that's right.
Now if it is already visited, okay, so if visited of given row and column, if it is already visited, so don't explore, so that you can simply continue. Don't explore again. Otherwise, what is your job? So first mark this guy as visited, or you don't need to do that. I can do that in neighbors. Okay, so what we do, mark this guy as visited. Fine. So, okay, multiple places you can do, you don't need to do that, but let's see. So we are going to get the neighbors. Okay, so list of neighbors, so get neighbors. So what to the get neighbors, what we are going to do, we are going to pass row, we are going to pass column, we are going to pass distance, which is going to take, so I can directly take 1 plus distance. This can be directly appended to the neighbors. Then what else? We just need to pass visited. Okay, if the earlier neighbor is already visited, then you don't need to go further. Is that clear, buddy? Please.
Yes.
Then
Then this get neighbor is not just giving the neighbor, right? You know, it is updating the visited also.
yeah, we can do that. It will update the visited also. That's why we take an visited array also. Visited thing also. Now what we do, so now it's time for us to find out the neighbors, right? So how do you find out the neighbors? So this is our direction, right? So this is my direction from directions. Yeah. So what is your job? Now you need to get the directed row. So row plus dir of 0, and directed column plus dir of
1.
1. What is your job? So if directed row less than 0 or directed column less than 0 or directed row is equal to, what is it, n, right? So we can, it can reach to n also. Can we do? Yeah, so this visited dot length is equal to n only. Correct now, buddy? Same
Yeah.
unequal, you can say visited dot length. So if it
And
is
m is equal to visited of 0 of length. Or the both are same right here.
that's it. So if it is n or directed column also n,
And
or what else? What else you need to check? Or if it is already visited, yes or no? If it is
Yes.
visited,
yes.
what else you
Continue.
can check? What else you can check? We need grid also, because if it is one, right, we should not consider, na? If the path is one, we should not consider, na, buddy?
Yeah, only 0 paths we visit.
Yeah. So if grid of directed row, directed column, if it is equal to 1, then you can simply continue. Otherwise, what you should do? First, you should mark this as visited, correct?
That column is visited.
Okay, so you mark this as visited. Then we just take, we will add to this a list of neighbors. List. Imagine if you don't get that, if you don't have that diagram in your mind, right? It's a hell out of. It's very tough to write this code, buddy, isn't it?
Yeah.
So what is our job? So for the new thing, so this is my directed row, this is my directed column, and whatever distance you already took, so that is your distance. Correct? The distance you already took, na? So because while passing the distance, you are passing 1 plus distance to the neighbor. So you will just take that. Okay?
Okay.
Great.
Grade will about to pass, right? Yeah.
Done. So finally, this is our last one, right? Return neighbors. Okay, so done. So what is our job? So you can simply get the neighbor and add to the queue. So queue dot add all of neighbors. If it is empty, it won't do anything. So that's fine. So once you are done, done. So if it is not finding in queue means you are not getting that. So you simply return -1. Done, man.
What is the return type of this one?
Integer only, na. So we are
Okay.
doing distance now. So
Okay, we're already passing the distance. Okay.
we did some mistake. So let's see what is the mistake we did. 0 0. Okay. This is too good, man. 0 0. Yeah. 0 0. We took directions. So 0 0 is true, and row column distance is this one, and row is not equal. So and okay. We should not do this. I think what is happening here, the first cell, right, 0 0 cell, which is already been visited, right, here. So we marked it as visited. So better we will not mark it as visited, then it will work. And other one also, what is happening, it's a problem with visited concept. I think we should not add here, because we are filtering here itself. The neighbors itself we are filtering, so that don't need to worry about it. So the first cell we will mark it as visited. What is happening, because of that it's not moving further. Okay, you can debug that. Yeah. Hope you understood, na?
Yes.
Yeah, that's it, buddy. So that's how it works. And can you do with DFS? Can we do the same with DFS?
Defer search.
Via recursion.
Yeah, recursion. or stack. You can use stack or recursion. Do man, recursion is beautiful here. So let me convert this into recursive code. So what is my job? So I am going to return the distance, right? So shortest distance. The only problem is recursion is going to be somewhat lengthier. So you have to explore every path. But when it comes to Q, right, you don't need to explore every path. The moment you find the n by n, right, so that is going to be your shortest path, you can return it because you are trying to go level by level, right? So it works. But this recursive, right, you have to find all the paths and find the thing. So let's see. So row, column, and we'll also take grade. We'll also take grade, and we'll also take distance, and we'll also take visited array. Same thing, I'm just doing it in recursion, but you feel like it is very easy code. Let's see. Boolean. Ajay, the moment I say easy, it is going to be struggle for you, right?
I don't trust those easy medium ones whenever you say. I should start thinking the reverse direction. When you say critical means that's easy. When it is easy, that's difficult. Your definition of easy and difficult is really confusing for me.
Yeah. Okay, so let's say when do you return? Okay, so if your row less than 0 or column less than 0 or row is equal to, okay, so before writing base case, let me explore all the paths. So okay, so if you think this is valid, then what is our job? So mark current row column as visited. Okay, so column row column as visited. What do you say? True. Then what is our job now? Now we need to explore the remaining directions. So in order to explore the remaining directions, you can simply, yeah, so you can simply return this distance. Okay, so let's return the distance. Okay, so I need to explore the directions. So let's do that. So what are the directions you can do? So let's take it as a DFS in order to make it simple. So one is DFS row plus 1 column, and whatever distance you take, so just take that distance and plus 1 and same grid and same visited. Right, so this is one. Then what is other direction?
Yeah, change the column,
Row
keep the same
minus
row.
1. And with row we will see bottom right and top left. And similarly you will find all these things, right? So column plus 1 minus 1. Is this correct? Everything is fine, right? Row minus, both are look same now.
Both are same. That should be column plus 1, I think.
So this is right, this is left, and then yeah. This is 1 0.
Minus 1 0. This is 1 1.
This is
Minus 1 minus 1.
this is
It's reverse 0 1. 0 minus 1.
it should remain same, right, with respect to this. One.
And that way, Srinu, that both are duplicate, right?
Yeah.
16 and 18 are duplicate.
Yeah. So what is going to happen? We should go to here.
Row and column minus 1.
So it is going to be 1 minus 1. Yeah.
Plus 1 minus 1.
1 minus 1. How many times 1 minus? How many times 1 minus? Okay, so minus 1. 1. Okay. I think we need to reverse it. So 1 minus 1. And what else we have?
Minus 1 1.
Okay, somehow.
That's why I was telling you, Srinu, to write it randomly. It would be easy.
But if I write this logic also, it's going to be okay. Let me do that.
That should be column minus 1, row plus 1. Yeah.
Okay. Let it be. Now we are done. So at every moment you will find a min value. So what you do? So you will get a min value. So every moment you will get a value, right? So we need to find out the shortest one. This is going to be very complex. Let it be, bro. So what you can do, so you can find total 8 values, and out of 8 values you need to see what is the shortest value and return that shortest value. Clear?
Yeah.
This is if I write it, then definitely what are the base cases here? Base cases is if row less than 0, column less than 0, equal to n, equal to n, or visited, you should return max value. So that will be eliminated. Correct now? And if row equal to n minus 1, column equal to n minus 1, you can return distance. That's it. Correct now?
Yeah.
Better you will write it, buddy. So I thought it can be simple, but it is going to be very complex. So let me avoid this. Let's go with brute for BFS. Okay, so we have. Can you try other problem? We have other problems.
Sure. Srinu, the new ones that we added in the sliding window, can you highlight that one? The new problem you added, you told, right?
This one, these two, right?
Just highlight the background or something. Okay.
Let it be red. And these are lead code articles on sliding window, but it's not a simple sliding window. All different levels we will see. You can apply DQ,
Okay.
some DPs, something. So future you can use it. For future you can, if you open this, you will get set of problems. Even if you open this, you will get set of problems. This guy has, in the bottom you will find a set of problems on stack problems and sliding window problems. And similarly here also you will get a set of problems in the bottom.
Sure.
Most of them could be repeated, but you will find some uniqueness. Few problems will be added, few problems will be removed. This will help you. So when you really want to practice, you can try other.
Those ones actually were solved, Srinu, in that page that you opened, right? We had that fruit basket problem and all that. We have already solved it, I think.
These problems. Few
Yeah,
of them
fruit
we might have.
basket.
Yeah, few of them we
Yeah.
might solve. Few of them we might not.
Okay.
You can do that. So probably, you can try this problem. I think you can give a try. With the current example, you can try to solve this one. Yeah, so walls and gates. Simple thing is, from a given gate, for each cell, what is the shortest distance you could see? From this gate, so to reach this cell is one distance, this cell is two, this cell is three, and if you do this, from here you can reach this in one, this in two, this is also in one step, and this is also in two distance, this is also two distance, this is three, and this is four. Do you understand this? It's the same as the problem we discussed, but you need to apply a little intelligence, very little. So you try to solve it. Let's see. So if you are unable to do that, I can explain this.
No, I think that's a premium problem. I don't think we can open it.
You are not lead code subscribers.
No, sure, no. We are Netflix subscribers.
Okay, I'll give my credentials then.
No, just take a photo of this particular problem and just put it in the document. Oh, even though that also we cannot write the code, right?
Yeah. Let's see. It doesn't take much time. Probably tomorrow we can discuss.
Sure.
Okay, cool then. So let's stop today.